My name is Dave Taylor. I read rocks. They have a story to tell. Metamorphic Rocks. This is Africa's Great Rift Valley. It stretches from the Middle East to the island of Madagascar. Quite literally, the forces below the earth are tearing Africa apart. It is a very active place, geologically speaking. Creation of a rift valley. This is how a rift valley gets created. One plate moves away from the other. The land between them drops, creating a rift valley. Signs of a rift valley. Cliffs formed by lava flows. Geysers and hot springs heated by mantle close to the surface. Mount Kilimanjaro and other volcanoes dot the country. All of these indicate the tremendous forces of the earth that are ongoing in this region of the planet. These forces bring about the final stage of the rock cycle. Both sedimentary and igneous rocks can be changed into metamorphic rocks. Metamorphic means changed. Forces acting on the rocks cause them to change. They are squeezed and heated, crushed and melted, compacted and twisted. They are changed. Sedimentary rocks change to metamorphic rocks. Igneous rocks change to metamorphic rocks. These rocks were once sedimentary, but over millions and millions of years they've changed. If you look carefully, you can still see the layers, but they are more compacted now, much harder than when they were first laid down. What happened to them, and why are they on the surface? Imagine once these rocks were covered by other sedimentary rocks. These younger sedimentary rocks crushed the older sedimentary rocks, and over the years changed them into, well, you guessed it, metamorphic rocks. And today, this is what we see. If we came back in a million years, it could look much different. Many of these ancient metamorphic rocks are sacred places to Australia's Aboriginal people. They have been here 50,000 years. Australia is home to some of the world's most unusual mammals, but the continent itself is equally odd. Its rocks are some of the oldest on Earth. The island continent is also the most worn down of all the continents. Unlike Africa, Asia, Europe, and the Americas, it is very quiet in a geological sense. These are the Three Sisters. They are a rock formation in Australia's Blue Mountains. They are metamorphic rock, but they are being eroded and turned back into sediments. Eventually, this material will form new sedimentary rocks, and the cycle will continue. If Australia has some of the world's oldest rocks, Europe can claim some of its youngest. The Alps are a mere 80 million years old, give or take a few million. They were formed towards the end of the Cretaceous era, when another supercontinent was breaking up. They are the results of a collision between two of these pieces. Much of the rock in what makes up this mountain range is metamorphic. This is one of the most spectacular places on the planet to hike and to study rocks. The mountains in the distance are in Italy, and I am standing in Switzerland. There are lots of ways to explore the Alps. This is one, the cogwheel train that takes you to the top of Mount Pilatus in Switzerland. Did any of us stop to notice that the rocks were metamorphic? Nope. The scenery was so wonderful that you just couldn't take it all in. Look carefully at this picture. The rock is metamorphic, and it clearly records the stresses that created it. What do you see? These are magma intrusions. Lava has forced its way into the rock, putting pressure on it. The red lines show how the original layers of rock have been twisted by the pressure put on them. These red lines show how the rock cleaved or split apart. Cleavage helps to identify the type of rock. Each type of rock breaks apart in its own unique way. Sparkly bits are shiny minerals that make up the rock, and the bright areas are where people have drilled holes in the rock to plant explosives to blast the rock apart to make room for a highway to go through. A cycle has a beginning and an end. For rocks, they are born of fire, and they end as fire. Eventually, all rocks return to the magma and are melted. How long this takes is a matter of where the rock formed. Millions of years may pass, even billions. You may have noticed that rocks change from one form to another without going through all the stages. Igneous rocks can become metamorphic without ever becoming sedimentary. Sedimentary may simply be melted and returned to the magma. Metamorphic rocks may erode and become sedimentary rocks again. Change is always happening in the rock cycle. Well, my work takes me all over the world, and everywhere I go there are amazing new things to see. What is down the road, I wonder? Every now and again I stop to wonder what is beneath the road. Over the years I've rediscovered my interest in rocks and minerals. I am sorry now that I forgot how interesting they are. I'm enjoying reading the rocks all over again. It really adds to the enjoyment of the trip. Next are a series of pictures with questions. These will help you review what you've learned. These rocks are known as Hoodoos. They can be seen along the Bow River in Banff National Park, Alberta. What type of rock are they? And what caused their strange appearance? These are the famous White Cliffs of Dover. They are made of chalk. Chalk is very soft rock. What do you think made these chalk cliffs? Why are they exposed here? What type of rock are they? Niagara Falls, Ontario. These falls are an excellent example of something you just read about. Can you explain it? What about the rocks at the base of the falls? Botanical Bay, British Columbia. This place is known for the holes in the rock. The ones found on the exposed bedrock often are home to small fish, crabs, and strange forms of seaweed. They act like small aquariums and are one reason for the name. What caused these holes? And what type of rock do you think this is? Percé Rock, Quebec. What do you think caused the famous hole in the rock? What type of rocks are these? Eventually, what do you think will happen to the rock? These funny-looking rocks are in the Swiss Alps. They are made of the bodies of small ocean-going animals. Can you explain how they were made? How did they get to the top of the Alps? What type of rock are they? What is happening in this picture? You should be able to explain how the three things relate to the story of rocks: the falls, the rocks, and the river. These are the famous Okotoks rocks. Something dropped them in the middle of the Alberta prairie. They are kilometers away from the Rocky Mountains. How did they get here? Churchill, Manitoba. These boulders were deposited on the shores of Hudson Bay. What do you think carried them to this place? Denali National Park, Alaska. This picture shows several of the ideas discussed in this ebook. Explain what you see in this image. Denali National Park, Tolkat River. What can you say about this image?